Page 80, bar graphs. Everyone's on here? You got your straight edge, the ruler, or your ID card, right? Cell phones are put away. Okay, if you try drawing the bar graphs without your ruler, it just looks terrible. If you're looking down at your work and you're not proud of it, it's not going to feel good, okay? Come on in. So you need to use a straight edge, please, okay? I've noticed a lot of people bringing in their like geometry sets. That's cool. If you don't have a straight edge, let me know. Okay, bar graphs. And we'll read this together. Bar graph is another way to visually represent data. So that's what we're doing in this chapter. Visual representations of data. The bar graph is used to plot discrete data. So discrete data is data that is not connected, okay? So it just has random values that jump, okay? Distinct values or intermediate values are not possible, okay? So for example, like if you were measuring the amount of people who ride the bus every day, and at 9 a.m. or at 8 a.m., there's a whole bunch of people on the bus. And then at 9 a.m., because people are now at work, there's not a lot of people on the bus. Okay? And then at lunchtime, maybe there's more people on the bus, because maybe it's lunch break. And then at 3 p.m., there's tons of people on the bus. 4 p.m., there's tons of people on the bus. But there is no connection between the times. Like, it's just random. Okay? That's discrete. Okay? The opposite of discrete is continuous. So like a baby growing. A baby cannot all of a sudden be 6 feet tall from nowhere. It has to experience all the heights in between. So it has to be 1 foot, 2 foot, 3, all the way till it grows up to be an adult. You can't just magically jump. That's continuous. Okay, so bar graphs are a way of measuring discrete data. And that's distinct values. All right. Also, another way of thinking of this is the number of students in your class. You cannot have like half a student in your class. Or if you're like selling tickets to a movie theater, you can't sell half a ticket or a quarter of a ticket. Okay, so there's only whole number answers. All right. The bars on the bar graph can be vertical or horizontal. That's completely up to you. And have spaces, okay, between them. Set the scale, label the axes, and give the graph a title, the same way you would do for a broken line graph. As with broken line graphs, the scale and the starting point on the axis affect the way the graph is interpreted. Remember I showed you those Fox News bar graphs that were like cut off? So it's misleading. They'll show visually a huge discrepancy, but it might only be like a couple percent. Okay, so we got to be smart about our scale. Okay? So here's an example. What do we do with the charts, you guys? The first row is just like X and Y, X comes before Y in the alphabet. The first row is X, and the second row is Y. And that's if you do vertical bar graphs. That's for vertical bar graphs. That's what everybody should use as their default. Like, just default to the vertical bar graph. Okay, so time is on the X, and the responding variable is in the Y. That's what everyone will be used to. If you do a horizontal bar graph, it's going to flip that, and you might get a little bit confused. So if you're kind of confused by this stuff, just stick with the vertical bar graph. All right, so they're going to have all these cities on the x-axis. Then they're going to have various bars rising up on the y-axis, just like this. So they got the cities on the x. They got the title for that axis. They got the population on the side and the title, and they have the scale going up by 500s. Looks like they're going up by 250s because every tick, you want to call it that, every increment is going up by 250. All right, and of course the title on the top. And I think everybody in this class knows what a bar graph is. So let's build one. A company tracked some software, blah, blah, blah. Okay. So let's put our title. Software. All right. We have, instead of rows, we have columns. Okay. So this first column is going to be the X. And this second column is going to be the Y. And to do this, like always, use a straight edge. And you'll get a couple lines. Make your graph. Just like that. Okay, we need our categories. So what's the title of the first column? Software. Okay. Software. This is weird. How software was obtained. So that's kind of a weird title. So we can put those categories in there. So and this is really weird. So I'm just going to go like this. 1, 2, 3, 4, 5. I'm going to do like a little legend. 1, 2, 3, 4, 5. Usually the categories are way easier to jot in. Like months or something, like January, February, March, whatever. These categories are ridiculous, and I don't want you to spend your time on that. Then the y-axis is percentage. Okay. So what's the scale for percentage? 0 to 100. And you can make your increments however you want. You can go up by 10s, you can go up by 50, you can go up by 25, whatever you want. I'm just going to go up by 25s. Because that's like quarters. Up by quarters. Now, when you draw your bar graph, you sort of have to center them. It's kind of weird. So like, do you see the center of, what I would do is put a dot in the center of all these categories. That's going to be the center of your bar. And like, I have a rectangle tool, you don't. So I can just do this. Like, I get it for free. So 58 would be like just past 50, like that. Now you don't have a rectangle tool. So you're going to have to like find the center and then make a rectangle. And all the rectangles should be the same width or else it looks funny. Next rectangle with that dot in the middle will be about 16. So just like that. Next one's only 10, so it's even smaller. Next one's 12, so bigger than 10 but smaller than 16. And the last one's 4, it's even just tiny. And it's your choice if you want to color them in or not. It's completely up to you. Maybe you want to do something cool like this. Completely up to you. As long as there's some notion of neatness. With a title on the axis, a title for the graph, etc. Alright, the next question has a vertical bar graph, and you'll notice that it goes against what I've always told you. You can see here that the time is on the y-axis and the responding variable is on the x-axis. So this goes against what I've always told you, responding on the on the x-axis. So it's weird, it's different, but I don't think it's going to really affect you that much. It's pretty straightforward. Because when you're age 10, this is her height. When she's age 11, this is her height. Okay? So obviously the bars are growing because she's growing. So what do they want us to do? Suggest 2 ways to improve the way the data is presented. Well, the data is not discrete. So a choice of bar graph is unwise. I would have probably chose the line graph. And that's what they want us to do in part B. So we have to redo this as a line graph. So you have to take all this data from this page and put it on a line graph. Do you guys want to spend time doing that? I don't really want to do a line graph. Okay, so what we'll do, I think we'll just move on. You guys want to do the line graph? I don't want to. Okay, so let's just, want to just like sketch it out? Let's just sketch it out. So like when she's 10, what's her height? Like 125-ish? So it goes from 0 to like 200. So let's just say it's like right here, 125. And they slightly get, they just do this, right? And then they peak. So this is all you need to do. That's a better way of writing it. So this would be like 11, this would be 12, this is her age, right? That's a better way of doing it because it shows you that it's connected. This kind of data is connected. Like, in order for her to go from 120 centimeters to 130 centimeters, she has to be all the centimeters in between. She has to be 121, she has to be 122. In fact, she has to be 122.1, 122.2, 120, and so on. Like, you have to experience all those heights in between. You can't just magically be 120 centimeters and then tomorrow you're 150. It just doesn't work like that. And that's what a bar graph implies. A bar graph is discrete. This kind of data is not. Okay, moving on. Ooh, 3-dimensional bar graphs. Ooh. Okay, so like if you use Excel spreadsheets and you put your data in the Excel spreadsheet, you can generate a nice graph like this, okay? So this is all computer generated, which most data is done, all data is done with computer nowadays. So the fact that you have to use a pencil and paper is kind of barbaric in a sense, but the only technology you guys have readily available to you is your mobiles, and you don't have Microsoft Excel on your mobile. So kind of just got to do with pencil and paper. What does this question want us to do? Give 2 reasons why the graph may be misread. All right, what's one thing that's weird about the bars? Yeah.
The fact the bars aren't all equal.
Yeah, not equal width. Okay, you can see that the January to March, and then here's the June. So they're showing like 3 months at a time here, and then 1 month for some reason. So when people read the graph, they might misinterpret it. And apparently there's one more thing. Does anybody see anything else? I don't see anything quite yet. Do you guys? Actually, I see something. Go for it. Good. Good. With the 3D, how do you know which one is it? Is it 10 or is it almost 15 there? Right. If it was like a wall, it would be the top of it, the front of it would be probably 10, right? Yeah. Now, people aren't always going to think that way, so that's also one other misleading. I can't spell today. Misleading. Okay, because it's 3D. You don't know if it's 10 or 14. Good, you guys. Seems like you guys are pretty fluent with graphs. Okay, what's next? We got some horizontal bar graphs about carbon dioxide emissions. Okay, so governments, environment, this is all stuff you guys should know about. Kind of like, this is a current issue in our globe. So what do they got here? Carbon dioxide emissions in the billions of tons based on the year. Okay. Which graph is better? So it's the same stuff. The only thing that's different is the... What's the only thing that's different? Zoomed in on which axis? The x. Good. So this one goes from 0 to 30 with increments of 5. Increments of 5. This one goes from 20 to 28 with increments of like 0.75. 0.75. Because every 2 is 1.5, right? So half of 1.5. Okay. So remember how Fox News like chopped off part of the graph and then they put it on their page? So that's like if you did this, if you just chop that part off and then blew it up. See how I can blow it up? Like if I only showed you this, well, not really, right? So that's all they're doing. And then they skipped 0 to 20. Okay. So which one do you think is better? And this might be a personal preference. Which one do you think is better? You think the first one's better? You get more accuracy with the second one. Would you agree with that? Okay, more accuracy for second graph. But I kind of like the first graph. Why do I kind of like the first graph? Anybody want to take a shot at that? Don't say easier to read because that's kind of vague. Like be specific. It's like the full picture. So you can see that from 1995 to 2005, it only really went up a little bit. But in this graph, it looks like this giant increase, when really it only went up a little bit. So so more accuracy for the second graph, but first graph gives the full picture. It gives more context. You guys know that word, context? It's like some background information, like I need to know everything about what's going on. So for a question like B, what were the emissions in 1999, I'm going to use the second graph because it's more accurate. Again, what do I know these increments are? If it takes 2 jumps to go up 1.5, I got to take 1.5 and divide by 2 because the 2 jumps. That way I know it's 0.75 per jump. And the proper word for jump is increment. Now, I'm not going to expect you guys to use increment. Just like every jump or every tick. So 1999, straight down, it's almost at this spot right here. So what is that spot if it goes up by 0.75? 23.75. So what is this spot? I don't know. 23.74? I don't think it's that close. 23.6 maybe? Dang near touching. So 23.65? Doesn't matter, you guys. 23.6 I'm going to put. And this is billions of tons. Now on your multiple choice exam, you just pick the one that's most appropriate, right? And on your written response, you're just going to have to draw graphs. So you won't have questions like this. Okay, what were they in 2005? 27? You want to go with 27? Sure, why not? And why might the more misleading graph be used to represent the data? Well, that's what we put for this. Or no, what are they trying to get at here? Why might the more misleading graph be used to represent the data? I think that's the second graph, the one that's more accurate, but it's misleading. So the second graph is misleading because it makes this looks like this huge increase when it's really not. So why might they use that? That would be a political agenda. So like maybe Greenpeace or something wants people to stop polluting. I guess that's their political agenda. You guys ever watch like House of Cards on Netflix? Yeah, there's like people trying to like do these like backdoor sort of like crazy things to get their political careers moving forward. Okay, what's next? Some data that can be represented using either a vertical or a horizontal bar graph can also be shown on a broken line graph. Each type of graph has its advantages for displaying certain kinds of data. Alright, so they're going to display it on a horizontal, a vertical. Which graph's better? What's the trend? Draw a broken line graph. Is the bar graph or the broken line one better? Draw the broken line graph so it's misleading, making it appear that the population declines significantly. Okay, so there's a lot in this question. So here's the two horizontal, vertical. So they're basically the exact same graphs, just one's going left and right, one's going up and down. And it says that the vertical seems to be better because you can see the population trend more clearly as you read the graph from left to right. Now that's complete garbage. To me they're the same. To me they're identical. But my personal preference, because my whole life I've seen vertical bar graphs my whole life, I would naturally just pick the horizontal or the vertical bar graph because that's what I'm used to. Okay, the population trend shows a slight decline. Does it? So this is what they do for the line graph. Watch what they do. They'll go from the middle to the middle. Oh, we're supposed to draw a line here. From the middle to the middle. And then from the middle to the middle going down. So this is how they would draw the corresponding line graph that goes with it from the centers. You can see that it has a sharp, or not a sharp, but some decrease. See how it decreases there? And that's the line graph that would go with this. Okay? So nothing crazy. I don't expect you to redraw all this stuff. Oh, and they have the line graph at the bottom of the page. See it? It's identical to what I just did. All you gotta do is from the tops in the center, draw the corresponding lines. And you can draw the dots. Whoops, that's way too big. Pardon me? Agreed. So these are the dots for the line graph, right in the middle. Okay, so it's a small decrease, yeah. And then they want you to redraw it so it's misleading, right? Do you remember that? So what they do to make it misleading is they chop off 0 to 30. And that's what gives you the full picture. Just like that Fox News misleading graph where they chop off the bottom and just leave the top. So it looks like a gigantic decline. And then here's the corresponding bar graph that would go with that line graph. And when they say stuff like does not seem, like that's just like, it's like an opinion, like it's not mathematically relevant. It's like how you view something, and it's an interpretation. So we're not going to really spend much time on that. Alright, so then it says, for number 5, draw the broken line graph depicting the same data. Which graph seems to be the better representation of the data and why? Okay. Daniel, this is about you. Or maybe not. These are some high marks. I'm just kidding, buddy. Didn't you get like over 80 on the first test? Attaboy. Okay. So I'm not going to expect you to draw a brand new graph. All I want you to do is draw dots on the middle, okay? And if you had a different color pen, that'd be sweet. Like red. If you draw the dots on the middle, then you don't have to spend all this extra time. Just connect. What's that? Think the bar graph's better? I agree. To me, they're the same. Either way, it's easy to read. I will say this, though. You have to make a decision on whether the data is discrete. Is the data discrete? Can you have, like, 1.5 test number? Is that possible? Or is it test 1, test 2? You can't have half a test, right? Yeah, it doesn't make any sense. This is unit test 1, unit test 2, and so on. So there's no in between. Okay, so jot that in. Okay. There is no in between. There is no in between for tests. That implies it's discrete. If there's no in between, it's discrete. Discrete should be a bar. Discrete should be bar. Okay, so the bar graph, technically, I think, is the better choice. Because what the line graph assumes is that you could do like half a test. So on the 1.5 test, he scored 60. Does that even make sense? No, he didn't even write a 1 in that. It doesn't make sense. So the bar graph's the better choice. You guys cool on that one? So I guess what I really want you to know is that discrete data is for bar graphs. It's when there's no in between. All right, number 6 here. Oh, this is just a huge section. Gosh. Okay, the next table, tickets sold until a rock concert is sold out. What is the general trend in sales? So what happens on a concert? What happens on the very first day? People are like, ooh, I'm excited. I want to get those tickets before they're sold out. So on the first day, you have the most sales. And then you can see this general trend where it is increasing, decreasing, or staying the same. Yes, decreasing. So when you see general trend, you only have 3 choices. Right, Abdurazak? Increasing, decreasing, or same? So for this question, it is decreasing. And then it says Darlene used the graphing tool on her computer, drew a horizontal bar graph and a broken line graph. Which is better? Broken line graph is just the lines that are just lines that are connected. This is a line graph. Yeah. Okay. Hands up if A is better. We only have one winner. Why is it better, sir?
Because it's more accurate.
No. Something to do with discrete. Can't sell half a ticket. So connecting with lines doesn't make any sense. No in between. Think about that. Half tickets? Quarter tickets? What if they sold you half a ticket? You sit on half the chair? Oh, I only get half the chair today. Or quarter ticket, you're just like right on the edge of your seat. It's really exciting. Right, so the bar graph is better. Bar is better since discrete. Good, we're just motoring on here. Love it. Okay, the next one is really common. This is really common in the newspaper, in magazines, okay? It's really common because what this allows you to do is compare two things on the same grid. Rather than just looking at one set of data, you compare two sets of data with the same criteria. So in this case, they're selling homes? Yeah. Okay, so you have new homes versus resale homes. The new homes are on the right and the resale homes are on the left. And what it allows you to do, same axis, same scale, and it gives you a direct comparison. That's what makes these so good. And these are very common. So what was the average price of a new single-family home in 05? Well, you just look at 05, and then it says new, so you're in the right column, and so 240. Okay? And then it's in the thousands, so 240,000. Part B, between what years was there a drop in the price of resale single-family homes? So resale is the left bars. So where is there a drop? 355 to 350, there's a small drop. So 2007 and 2008. In 2009, oh, we're looking in the left bars. Oh, and it went from 350 to 330. So up, yeah, it happened in 2009 as well. So there's two answers for the part B. And C, generally, what is the general trend in the differences in prices? For example, which costs more or less of the two types of units? In which years is this not so?
So which bar is always bigger, typically? The new homes, right?
The new homes are always going to be more expensive, except for 2 years. Which years did that not happen? 2006 and 2007. So 6 years it happened, 2 years it didn't happen. So I guess there is leaning towards one of the sets of data, okay? And that's part C. And then it says, yeah, I think that's okay. Okay, so question 7, they want us to draw a double bar graph. So this is what's going to take up our time here, drawing a double bar graph. And then they do bar graphs that go below the axis, and then stacked bar graphs. So I might have to just pause. What is it, 210? How long have I been going for? 35 minutes? You guys feeling restless? You want me to be done? Yeah, okay. So what time are you guys out of here? 247? 247. So we'll give you half an hour to do your homework. Do you think half an hour is too much time? I do. Okay, 10 more minutes of me. Okay? You guys want to stand up? Get your bodies moving? You want to do that? Maybe Hazik could do some bicep curls? No? Okay, let's just keep motoring along here. Okay. So they're doing, let's take a look. What does the next quiz look like? Remember yesterday I did the quiz on the board? Let me just double check this quiz. You like that, eh? Okay. Okay, so let's do this. You have to draw your axes. Now, what goes on the left, what goes on the right? This is household expenses. So, what's an expense? Yeah, what is that? What unit would that be? Rubles? Pesos? Dollars, okay. So here's expenses. And on the bottom we have category. What are the categories called? Item. Alright, now this is where I'd be a little bit clever. Food and drink. F&D. Clothing. CL. Heat and electricity. Health. Transportation. Communication. Recreation and culture. Education. And eating out. Okay, now we need a scale for the y-axis. So, when you're doing your scale, you need to realize what number do I need to at least get to? What's the biggest number? What's the biggest number? 176. What's the lowest number? 2. 6, whatever. Tells you that you need to go from 0 to at least 176. You want to go to 200? Let's go 0 to 200. And then you can do your scale from there. And what I always do is just use halves. So what's half of 200? 100. What's half of 100? 50. Now you can count by 50s. 50, 100, 150. What's half of 150? Or pardon me, what's half of 50? 25. Now you have a pretty good scale using halves. See how that worked? I just use halves. Everyone's comfortable with halving, I think. Cut things in half. So start with 200, cut that in half, get 100, cut that in half, get 50, cut that in half, get 25. Now I'm just counting by 25s. 25, 50, 75, 100, and so on. Now I got to do a double bar graph. That means for each category, I'm going to have 2 bars. Okay? Okay, so food and drink for the low-income households, those go to 104. So just past 100. Now I'm going to change color and do the all households with children. This one goes to 140. So just past 125. And then what I'm trying to accomplish here is the same width for each bar centered around this category F and D. So I kind of missed. Maybe I'm lucky because I have a computer. If you make a mistake, it's permanent unless you are sketching really lightly with your pencil. If you're using a pen, you're toast. You screw up once, you have to scribble it out. So pens are no good. Okay. And I use different colors because I can. if you don't have different colors, you could like color one of them in and leave the other one blank, right? And you can continue on putting this data in. Then what will happen is you'll have a nice representation of the data. And then you can explain the trends. And this is like an example of what will be on your written response in the test. It'll just be like, here's some data, make a double bar graph. It's easy, right? Okay. So how will I mark your double bar graph? Well, there will be a mark for, what do you guys think it will be a mark for? Title, good. Did I have a title here? Where's my title? So I lost a mark. Well, you put a title on the X and the Y, so maybe you'd only lose a half mark. Okay, so 3 things for the titles, that'd be a mark. And then probably a mark for neatness, and then probably a mark for accuracy. Is it neat? Is it accurate? Is it titled? Titled. So 3 marks. Is it neat? Is it accurate? Is it titled? Okay, so finish off this double bar graph on your own. And then you can answer the question, explain the trends in spending of the lowest income families compared to all families. I don't think it's going to be that difficult or surprising to think that the lower income households would probably spend less money on things like recreation, education, eating out at restaurants. And then what do you notice that's similar? What's similar? Heat and electricity. Well, everybody's got to pay for electricity, so that's similar. Yeah, communication. People all have phones, right? So that's what they want you to do when you're explaining trends, you know, with the double bar graph. They want you to compare. Okay, so make comparisons. So finish off this double bar graph. And then I'll stop talking. And then for practice your skills, homework. Work on 1 and 2. Okay, practice your skills 1 and 2. And finish the bar graph that you're working on right now.